Okay, this is lesson 8.2. If you've got your textbook, we're on page 326, and we're talking about composite figures. Composite figures are figures that are made up of triangles, squares, rectangles, semicircles, any other two-dimensional figures, and they're just kind of put together. So here's a composite figure. It's made of a square and a triangle, kind of squished together here. Here's a rectangle with a semicircle on top. Those are composite figures. And to find the perimeter of a composite figure is just like finding the perimeter of anything else. You add up all of the sides. So to find the distance around the figure, we're going to add up all of the sides here. This composite figure has 4 sides. Here on the side, up along the top, down here on the angle, and then on the bottom. This dashed line is important if we're going to try to figure out different things, but it is not one of the sides that we would add up. We don't add up all the numbers, we add up all of the outside sides. Here, we've got a side that comes down here, one along the bottom, another one up here, and this semicircle around the top. This dashed line through the center here is not an outside line. Now, they want us to estimate a perimeter using grid paper. So they give us this figure down here. When we do these estimates, all of this red line here, these are all worth 1 unit. So you go around and count. Here's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20 units going here. But these slants, they estimate these to be 1.5 units. As you can see right here, the slant here is worth 1.5. It makes sense that it's longer than 1 because it is the diagonal on this triangle. It's called the hypotenuse. You don't have to worry about that right now, but it is longer than either of these legs of the triangle. 1.5 is not a very good estimate, but it's better than just calling it 1. So it is longer than 1. So we'll call it 1.5 is what they're saying. So if we're going to do that, we had 20 that go around here. And here's how I like to write that. I like to write we have 20 that are each worth 1. So 20 times 1 equals 20. And you might say, well, that's pretty obvious. 20 times 1 is 20. But when we have these diagonals to put in there, we count these up. There's 1, 2, 3, 4 diagonals coming down this way. And then 1, 2, 3, 4 more diagonals coming down this way. So that's 8 diagonals. And now each of those 8 diagonals is worth 1.5. So multiplying by the 1 was pretty simple. Multiplying by 1.5, although not terribly difficult, we do need to do it, and I don't want to forget it. So I just keep it the same. So I multiply here, I multiply here. Remember, 1.5 is really just 1.5. So 8 times 1.5, or 1.5 eighths, would be 8 plus 4, or 12. You can work that multiplication out on the side if you want to, but it is 12. We add up all of those, and we have 20 and 12. That's 32. 32 units to go around this. Oh, and they did come up with the answer 32. They are brilliant. Then they have these 2 down here for us to work on your own. And I will do the 1 unit increments first. Across the top here we have 1, 2, 3, 4, 5, 6, 7. So this line right here is 7 units long. And you might think, well, this is just a half of a unit. It doesn't really matter. We're just counting this line across the top, which goes 7 boxes long across the top. Here's another one along the bottom that goes another 7. 7 and 7 is, of course, 14. So for number 1, we will have 14, and remember each of those is worth 1, so 14 times 1 is 14. And then we have these diagonals, 1, 2, 3 units, 3 slant units or diagonal units coming this way, 3 more coming back this way, so that's 6. 3 more going here, that's 9, and finally 3 more going here, that's 12. So I have 12 of those diagonals, which are each worth 1.5. And 1.5 times 12, or 1.5 12s, think 1 12 is 12. A half a 12 is 6. 12 and 6 is 18. So 1.5 times 12 is 18. We add these up and we get 32. And you might think to yourself, oh, are these always going to be 32? Our example was 32. This one's 32. No, they're not always 32. Number 2. We'll go along and do these flats again. Along the bottom, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Along the bottom, 10. 1, 2, 3, 4, 5, 6, 7, 8 here. So 10 and 8 is 18. 1, 2, 3, 4, 5 along the top. 18 and 5 is 23. And then 1, 2, 3 here. 23 and 3 is 26. So I have 26 each times 1, which is, of course, 26. And then I have these diagonals. I have 1, 2, 3, 4, 5. So 5 diagonal units. Each of those is worth 1.5. And 5 times 1.5 would be 7.5. And I write it off to the side here because remember when we're going to add these we need to line up the decimals. And you might say there is no decimal in this number. But remember when you don't see a decimal it's behind the number just like that. I'll even annex a 0 here to make it even more clear what we're doing. Add this up. 0 plus 5 is 5. Bring the decimal down. 13 and 3. 33.5 units. Yay, it wasn't 32. Close though. So those are the on your own examples. And we're still finding the perimeter. I like these problems better. They don't have that grid on there. When we look at this figure here, we think how many sides go along this? And there are 3 sides. There's a side right along here on the bottom. That's 6 feet. There's a side that goes up along here. That's 8 feet. This 10 feet diagonal is not one of the outside sides. So it's this 10. It's useful information, but it's not part of the perimeter. We have to find this semicircle that goes along here, and we'll need that 10 to do it. That's why they gave it to us, but we have to find that. So when we add these up, remember, let's just start with these. There's a 6 and an 8. So for example 2, we have 6 plus an 8, but we have 3 sides, 1, 2, and then this curve. So we add 6, 8, and now we have to figure out what that is. Well, we're going to look for the circumference as if this were a whole circle. Remember that circumference equals pi times diameter. If that were a whole circle, that diameter is 10. So the circumference equals 10 pi, but we don't want the circumference. We want half the circumference. So half the circumference would equal 5 pi. Now we can take that half the circumference, go up here, add this on there, 5 pi. And we're going to add these 3 numbers up. Actually, we can't add all 3 of them because they're unlike terms. This is the pi term. These are constants. 6 plus 8 is 14, so I have 5 pi plus 14. If you wrote down 14 plus 5 pi, that's still a correct answer, but convention would tell us we put our variable term first and then end with our constant. And we'll put this in parentheses and feet afterwards. If I did not put it in parentheses, then the feet would only apply to the 14 that it was touching, and it would not apply to this 5 pi. So that it applies to this whole thing, we put that in parentheses with the units on the outside. So that was example 2, and now they give us 2 problems down here. And here we go. It's actually the teacher's edition, so I have my answers written in down there. Pretend those aren't there. Number 3. This purple problem is a lot like this blue problem up here. There's 3 sides. I have a side here, and then this semicircle of a side here. 26 is important, but it's not part of the perimeter. So we'll add those up. We have 10 plus 24 plus, now remember we're going to find the whole circumference. And you might do this, instead of finding the whole circumference, you could say the length, we'll use a little cursive L so it doesn't look like a 1, length of and then just put this semicircle in there. If you want to, you can do this. Length of a semicircle is pi times radius. It's the same thing we did up here. We found the circumference as pi times diameter, and then we took half the circumference, so we had pi times the radius. And we're just kind of skipping a step if we use this formula right here for the distance of a half circle. So we'll use that, pi times radius. The radius, this is the diameter, 26, so the radius, of course, would only be half of that. Radius is half of a diameter, so it would be 13. So it would be pi times 13, which is just 13 pi. Put that up here, 13 pi. I have 3 sides on this figure, and I have 3 numbers that I'm adding up. So I got them all counted. 10 plus 24 is 34, plus 13 pi, which I cannot add because it's a pi term. So I have 13 pi plus 34 in parentheses, and the units are centimeters. And then number 4 on your own. This figure, it says, is made up of a square and 2 semicircles. Well, it's important that they tell us it's a square because we need to know that all of these sides are 8 meters. These are 2 outside sides that we need to know, 8 meters and 8 meters. We need to know this because it would be the diameter of this if it were a whole circle. So we need all of those dimensions. And there are 4 sides here, flat, semicircle, flat, semicircle. So we'll add them up. I have an 8 plus the semicircle plus 8 plus another semicircle. So we'll figure out what those semicircles are. Remember, we came up here, the length of a semicircle is pi times radius. Remember, radius is halfway across. This is 8 meters all the way across, so half of that would be 4. So pi times 4, or 4 pi. So that's for one of the semicircles, 4 pi. Of course, this also would be 4 pi. I'll put 4 pi in here for the first one, 4 pi in here for the second one. And you might say, well, why didn't you just use 8 pi? Count that as a whole circle. And the way I like to do it when I'm doing perimeter, I have a number on there for each side. There are 4 sides here, so I'll have 4 numbers here. I'll put them together right now. 8 plus 8 is 16. 4 pi plus 4 pi is 8 pi. So I have 8 pi plus 16. I don't add these 2 numbers up because they're unlike terms. I'll put this in parentheses, and the units were meters. Excellent. Well, now that you watched that lesson, you should be able to do this homework. Journal page 174, lesson 8.2. Remember when you're doing these that the slants are worth 1.5 and that the straights here are each worth 1. This is actually made up of all slants and no straights on this one. Here you're going to have to add 1, 2, 3, 4 sides up, and I get that there are 4 numbers here, but those are not the lengths of the 4 sides. You'll have to put these 2 together to get the length of that side down there. And this dashed line here and this line right here should help you figure out how long that line up top here is. On this one, you do have 4 sides. You've got this 8 here, 8 up top here, semicircle, semicircle. You'll need this 5, which would be the diameter of the circle, to calculate those semicircles. Here, find the perimeter of the swimming pool. It's all straights, but you're going to have to figure out what this length is here and this length is over here. And then you'll be able to figure out this problem right here. Tile costs $15 per yard. Look at this is in feet. You'll want to convert it to yards before you do this one. Okay, you can switch over to the homework video for this one, which is also on YouTube. Have a great night. See ya!